to show you guys how to do your notes today for lesson 11. We're going to be doing proportional relationships. So you're going to need your loose leaf paper. And to start off, your holes are going to be on the left side. Your margin is going to be on the left side as well. You're going to fold it in half. It's right about there. Make sure you make your crease. And you're going to draw your line down the middle so you can take your notes. We're going to ask questions and then we're going to answer them. Up top, you're going to have your title in the upper margin where the very top is where that big space is. So your notes are going to say lesson 11, proportional relationships. And then up top here in the corner, you're just gonna write week 18. Okay, my first thing I'm gonna look at and I'm gonna ask is, what is a proportional relationship? We've been talking about it for the past week now. Just to review, a proportional relationship is a ratio. So on the right side, you're gonna write a ratio between two quantities. That is constant. Okay, we call that a constant of proportionality. That means it goes on and on and on, and it does not change whether it's the numerator or the denominator. It stays the same no matter what. So my question is, what is a proportional relationship? Now I'm going to skip a line, and then I'm going to talk about how we know what's a proportional relationship. So last week I drew a table on our Jamboard, and we looked at a graph. The graph must go through, that line has to go through the origin. We said that was 0, 0. And that line also has to be straight. Okay? The question again is, how do I know a relationship is proportional? Okay, I know that the change is always going to be at a constant rate. It's always going to stay the same no matter what. That equation that we're going to use is called y. Oops, sorry, I'm going to cross two lines out. I made a mistake. Y equals k. This is why you write it with a pencil. Kx, that's my equation, okay? Where there is no y-intercept because it goes through 0, 0. We call that a direct variation. Big words. Okay? My next thing is, what is the constant of proportionality? Okay, it's my rate of change. Or also known as your slope. That's your m. Okay? So the ratio of the amount of change output. That's your y. Sorry, that's your y. To the change in your input. That is your x. Okay, so it's going to look like the change. Okay, that triangle is a symbol for change. It's like a shorthand way to write change of y over the change of x. My question again is, what is the rate? Sorry, constant of proportionality. Okay, so my y equals kx. That is my equation. Okay, so we got to make sure when we use that equation, it's only when the value of y is 0. Okay, that means when the value of y equals 0. Okay, so let's do an example together. James sells 3 pencils for $2. What is the rate of change? Okay, so he's selling pencils, and we want to know what the rate of change is. Well, to start off, let's start off the easiest way. Let's make a table for pencils and how much they cost. So my pencils is my x, my input. My cost is my y, my output. Okay, so let's say he doesn't sell any pencils. He's not gonna make any money, right? So if he sells 3 pencils, how much does he make? $2. So if he sells 6 pencils, so double those pencils, he's gonna make double that amount. He's gonna make $4. If he sells triple the amount, so 3 times 3 equals 9, he's going to be selling $6 worth of pencils. Okay, so there's my table. So let's look at the rate of change. How do we find that? Well, all I have to do is look at my numbers from 0 to 3 and see how far it jumped. And then I look at 3 to 6 and look at how far it jumped. Then I look 6 to 9 and see how far that jumped. Every single time, whoops, let me move it up so you can see it. Every single time we jump, we add 3. So 3 to 6, we add 3. 6 to 9, we add 3. And then let's look at the rate of change for 0 and 2, for 2 and 4, and then for 4 and 6. Every single time from 0 to 2, I add 2. 2 to 4, I add 2. 4 to 6, I add 2. So my change in y over my change in x. My change in y is 2. My change in x, it's all the same, it's 3. So that if I double it, I have 4 over 6. If I double it again, I have 6 to 9. Sorry, if I triple it. Okay, so my constant rate of change, my y of x, my y times kx is 2/3 times x. That is my equation. My question over here is, how do you look for a proportional relationship in multiple representations. Okay, so if I wanted to look for a proportional relationship, I can look for it through a table, or I can even use an equation. There's two ways of doing that. Okay, we're gonna turn our paper around. We did it in a table. We did an equation. Now let's do it in a graph. Okay, I don't have room on that side, so I'm gonna flip it over and do it on the other side. And I'm going to fold my paper. So now my holes are on my right side. Draw my line. And I'm going to make my graph. So 8, 6, 4, 2, 0. Okay, so I'm looking at these numbers right here. And then I have 9, 3, 6, 0. So my 0 is my x-axis. And I'm gonna space them out evenly, so 3, 6, 9, I'll go up to 12. Okay, so my first point is 0, 0 on my table. So I'm gonna write that up here. My next point is 3, 2. Plot my point there. Next point is 6, 4 and 9, 6. So 6, 4, 9, 6. Draw my line. That's how I make my graph. Don't forget to label. You don't want a naked graph. Okay? Now for the second part of our notes.